So, as announced, our next talk will be Leveling Up Your Security by Mark, and I'll just hand over to you.
Cool, thanks. So, my name is Mark Hillick. I work at Riot Games. My original talk was in 2015, so quick show of hands, who was here in 2015 for it? Okay, so practically a new audience. Awesome. Who plays video games? All right, cool. Who has heard of Riot Games? Who has played League of Legends? Who has played any of our other games? Working really hard on putting the S in there, so stay tuned. And no, I cannot tell you any of the games we're working on, but yeah, they look pretty cool. The talk's going to be split up. Quick introduction into who I am, who Riot are, and then we're going to do a really quick snapshot of 2015, which seems to be useful considering most people weren't here. And then a lot of the talk's going to be based on 2018. And then we're going to finish with like the futures section. So staying with the gaming analogy, I've called that getting to the Nexus. We hope we have a better sort of success rate at getting to the Nexus than we do when we play League. Cool, so who am I? I'm older than I'd like. When I presented in 2015, I didn't have as many gray hair. I'm Irish. I do infosec. I've been working at Riot for 5.5 years. I've got about 17, 18 years experience in the industry, and most of the time I'm not actually doing work, I'm trying to surf. I moved to LA, so you know, surfing in Southern California is a lot easier. So Riot, these are the numbers with regard to the amount of players that we have. As the screen shows, it's a lot of players, right? And that brings the challenge of scale. So one of the problems that we've always had within engineering, and security is no exception, is how do you do things at scale? And doing incident response, triage, etc., is quite hard when you've got this amount of players, because with this amount of players you need an infrastructure, and that infrastructure has to be very diverse, right? Our players are across the world, and how many people, when they lose in video games, they blame lag? Does anyone lag? Yeah. So we don't want people lagging. So genuinely, most of the case, people don't lag. A lot of the time, it's untrue, which might be a surprise that gamers lie, but it is true. So in order to make sure people don't lie, we have a very diverse hybrid infrastructure that's spread throughout the world so that it's close to the players. But that doesn't make incident response or doing infosec very easy. This is esports. This is absolutely nuts. The people that play esports have the same working visa that, for example, David Beckham or Zlatan has to play in the retirement football league in the US, right? So you've got like an 18-year-old playing League of Legends, comes from Europe or China or South Korea. That's on the same visa that, you know, Zlatan, Beckham, Thierry Henry, etc. are. Like, that just blows my mind. And does anyone know where this is from? No? So this is the bird's nest. This is the stadium that the Olympic Games were in 2008. So in 2017, League of Legends World Championship was in the bird's nest, which is pretty unreal. Ultimately, what we do, everything is about the player. So the example I talked about in 2015 was with the Poodle vulnerability. So most people patch the Poodle vulnerability immediately. We couldn't patch it immediately because a lot of our players actually run on XP. Most of our players are in Asia. A lot of those players run XP, not always legitimately. So the problem with that is that if you run XP, you actually need lower ciphers. So we couldn't patch because we needed to allow SSL v3. And we did patch eventually, but I wanted to make that point to illustrate that we always think of the player. So it's not risk versus business for us when it comes to security. It's actually, will this affect the player? Will it affect the player experience? So in 2015, when I was here at BruCON, I lived in Ireland, a really beautiful country. As I said, I've moved to LA. Just before I moved to LA, living in Ireland, Brexit happened. So I was like, cool, I'm out of here. Little did I realize what was going to happen when I moved to the US, but But I live in the Republic of California, so I'm okay. 2013, first year at Riot, month 3, we lost the password database. Not really a good experience. However, it's a phenomenal way to learn a network. Once you learn a network and incident response, you will never forget it. It's like, you can't, even if you try to. What I learned during that is that we had a severe lack of visibility. And by that, we were doing incident response, taking logs off individual servers, and then piling them on. So League of Legends went through this like hockey stick graph. And what happens if you're player focused and you go through a hockey stick graph, you want to serve the player, right? So you will add more capacity, build more network. Security is typically an afterthought because you need to serve the player in the first instance. But what happens with that is that eventually it will come back to bite you. So 2013, it came back to bite us. We got pretty badly owned, and we lost the password database, and we lost a version of an unreleased game that was a prototype via our founder's Twitter profile. So that was a pretty awesome experience, but it was a really good way to learn a network. And as you can see, I've got pretty good art. I did not do any of this. We've got much more creative people than me, and it's pretty inspirational to see, you know, what they do and how they serve the player. But ultimately, this resulted in firefighting for us, right? We had a lot of vulnerabilities that we caused, but then we had things like Poodle, Heartbleed, the Bash vulnerability, with various web app issues. So we were constantly firefighting, and it was emergent. And then we made decisions like this. So when you go to the cloud, you've got the developer's like, I want to go to the cloud really quickly because I don't want to go to ops, because ops will tell me it's like a 4-week lead time to order a server, then another 4 weeks to get the server, and then another 2 weeks to rack the server. So when the cloud came out, everyone went to the cloud, and then they needed a test version, and then they needed staging, and then they needed to be in multi-regions. And again, thinking back to player focus, if we constantly want to serve the player, we're like, yeah, we'll give you that access, we'll connect you. And this is previous to the days of direct connect in AWS. So we end up with a spaghetti junction, right? And this is like another element of emergent work. So we like to call this the wild, wild west of computing. Can you guys actually see that? Can you see the, or does the light get in the way of the image? So, yeah. So by iterating really quickly and innovating, what we wanted to do was to serve the player. But basically, we were like cowboys every day. We had blast radius that was super wide. We had shared accountability, and with shared accountability comes no accountability. When you've got no accountability, you end up with a ton of tech debt. So we were like, how do we fix this, right? How do we get people engaged to actually fix this security debt? And when I was here in 2015, I talked about this statement from Etsy. So we never wanted to be the security team in the corner. We wanted to be embraced, and we didn't want to be ignored. So we wanted to be brought into projects. So that's when we really changed our approach, and we started to be like collaborative, to work with teams, and to like reach out. So in 2015, I talked about a couple of ways that we did this. So the first way was t-shirts. T-shirts are a phenomenal gift. People love t-shirts. It's incredible. So this is NAR. So anyone who was like a really good security champion, we were like, hey, here's a t-shirt. And they walked away with a smile. The sign that this was a success was when someone came to us and were like, hey, you give me a t-shirt for being a security champion. I washed it too aggressively. It's unsurprising that we had a geek and they couldn't use a washing machine. But they washed it too aggressively, and they were like, hey, can I have a new t-shirt? And we gave them a new t-shirt. And yeah, it was a really good way to celebrate success and make people realize that security is fun. So another way was we used tools that the rest of the engineering organization were using. And this particular one is RFCs, requests for comments. And this is where we write a philosophy or a proposal, and then we send it out to the rest of the organization, and they give us feedback. And it's super useful because it's incredibly collaborative, and it gets people involved, and ultimately it gets people outside of security also owning the solution. So within Riot, it's a very feedback-oriented company, and RFCs are no exception. It's not an approval process, it's about receiving advice. And when you receive that advice, you basically iterate through your document. So think of the document as code or pseudocode, and it has versions, and then ultimately you get it adopted at different scopes. So you have a high-level scope, and that's Riot, and then below that you've got different products like League of Legends, Game 2, Game 3, Game 4, etc. And for security, when you want to drive change, you typically want to drive change throughout the organization. So the difficulty that we have is that most of our RFCs need to be adopted at the top-level scope. One example is we wrote a secure office RFC, which might seem obvious to everyone here, but when you have a company of gamers, no one wants to think of security within their office because it will stop them playing games. I don't know if you know, but most games don't actually work on HTTP or HTTPS, right? So they're really good at like finding holes through firewalls. So that's a big challenge that we have in our 20+ offices. And when we wrote that RFC, we were like, hey, this is awesome. We had 140 lines. We got 850 lines of feedback. So for every like one line of RFC, we got like 6 bits of feedback. But what happened was we went from an RFC that had like 60% alignment or 40% alignment to an RFC that was 70 to 80% of what we wanted, but 100% alignment. So it's really important that you get alignment, otherwise your like, you know, solution or product is just going to fail. So this is the goal of the RFC, this is the why, and this is the how. So if you remember in the incident that I talked about, we had no real visibility. We were just grabbing logs from individual servers. We didn't want that, right? We wanted visibility into the network. We wanted like login going to a central place. And we wanted to be able to like tell our executive team or tell other people how bad the incident actually was, as opposed to like sticking our finger in the air. So this is what an RFC actually looks like at Riot. Can everyone see that, or anyone not see it? But basically, at the very top, you can see that it's adopted. You can see the scope, and then you can see like a bunch of action items, what the problem statement is. And then we've got like version history, stakeholders, and then a bunch of other stuff that's like secret sauce that I have to take out. But we use Confluence, and we treat everything as code, even our documentation. So the final thing I talked about in 2015 was our bug bounty program. We launched our bug bounty program with HackerOne in November 2014. And I think as of BruCON 2015, we had paid out $500,000. We have now paid out about $1.8 million, which is a significant increase. When we launched the product, or sorry, the service, we had 70% of our sprint time for our AppSec team being taken up by bug bounty. That quickly reduced within a few months to 15 to 20%, and now it's currently sitting at 5%. The really important thing for us was always being grateful to the researchers. So we wanted to treat the researchers like our players. So a researcher-focused bug bounty was our philosophy. As of 2015, we had some really cool vulnerabilities, some really bad and embarrassing vulnerabilities. I think at the time, cross-site scripting was the biggest. So that's really where we were in 2015. So now we'll move to the 2018 section. So as I said, 2018, I now live in a place that has sun. I had to bring a whole new wardrobe here. Europe in October is very different from Southern California in October. My sandals are no good, my shorts are no good, I need a coat. But what's changed, right? So where are we in 2018? The security team is not this big, but the security team has doubled in size. We now have around 50 people. We have multiple teams. We've got platform security, so that's our team that's accountable for our platforms. We've got bare metal, we've got multiple cloud infrastructure, we've got an internal cloud. Then we've got our SecOps team, so that's a team that's accountable for like incident response, triage of incidents, threat intelligence, red team, blue team, purple team, whatever you want to call it these days. But our red team and blue team within SecOps work really closely together, and that's a super important point for us. Like, they're not segregated. They help each other. They work together. Then we've got our Riot security team. So we're a games company, so we can't call it corporate or office security because that would be too corporate. So we call it Riot security. So that's all our office infrastructure and our development infrastructure. And then we've got our AppSec team, that's application security. But we've also added anti-cheat. Apparently people like to cheat in games, which is interesting. You'll find when your main demography is like 14 to 25-year-old males, they don't always react with the most mature decision. But as a security person, that gives us really good job security. And we'll talk about some of the stuff that anti-cheat have done. So 2018, right? Where is RFC 242? So RFC 242, that's our secure office RFC. We now have it compliant across the world. We've actually iterated through version 1 onto version 2 of that solution within 3 years. So this is 20+ offices worldwide. Any office that needs code access has to be RFC 242 compliant. Otherwise, it can't be accessing code. You may think that's obvious, but we had publishing offices that had code access. We had finance people that had code access, right? So the horse had truly bolted from the field by the time security got there. But now we've tightened that up, and everyone is aligned, right? We've had a complete culture shift, and everyone has come onto the side of security, and it's like, hey, not everyone needs code access. We have a lot of automation. We predominantly use Salt Stack for a lot of our office security infrastructure, and a lot of air miles, because a lot of people these days think that servers don't exist, but someone has to rack the servers and rack the IDS and rack the firewalls and rack the proxy servers. So a couple of the team were, cracking up the air miles. And then what we've got from it is centralized login. We've got visibility into our network, visibility into our hosts. And one of the things I talked about in 2015 was we treat our office as code. So every single office can be represented by a JSON file that we host that's machine readable, and we can query it to figure out, is this office secure? Which is phenomenal change from trying to figure things out in 2018. And what we've also done is, working in the game industry and Riot specifically, we have a very specific threat intel that other companies typically don't have, right? So the standard like signature stuff that comes out from the various vendors just does not work for us. But now with our own RFC 242 infrastructure that's heavily open source, we have actually integrated our bespoke threat intel into that. So this is what it looks like on a daily basis, and hopefully I've taken out all the secret sauce. But as you can see, all IDS systems go to the one point, and then you can drill down into each individual IDS system. So that's, again, like huge for us. We've also changed how we do packet capture on the network. So for those of you who use Moloch, this is Moloch. It's been a great success for us. With version 2, we've actually reduced the cost of the RFC 242 stack by 60%, which has been huge. So finance like us, the business people like us, and we used to use Security Onion. We've ripped that out, and we just use Suricata, with a couple of our own additions, obviously. But what we've really changed from V1 to V2 is we own a lot more of the stack, and it's a lot more I can't even say that word, automated. It's amazing how much harder it is to speak up here. But it's like phenomenal change, and everything is much more visible. We can iterate quicker, and we can spin offices up and down, but we also know the status of every office. Cool. So does anyone recognize this? So the answer should be no. The reason it should be no is this is what it looks like if you're cheating in League of Legends. So you should have said no. So I don't know how well this looks with the light at the back, but there's like circles and then smaller circles. And basically, this is scripting software that enables the player to basically automate a lot of moves, right? So they don't have to do combinations. They could potentially also have cooldowns and things like that monitored. But it's super frustrating. Like when you're in game and someone cheats, it's like an absolutely horrible experience. And scripting is essentially where third-party programs forcefully attach themselves to the game client, and then they use the client's memory and functionality to basically to accomplish moves that are like super difficult, right? Another cheating thing that we have is boosting, which is where you give your account to someone who's much better at the game and they like boost you up. And then botting. And botting is essentially where you have the game input simulated like through AI essentially, and that's to level up accounts and then sell the accounts on eBay, etc. So now that we have the anti-cheat team, one of the things that we're seeing is that a lot of people who used to write malware are now actually writing cheats. And if you think about it, it's pretty obvious. Like if you write malware and you're like, hey, I'm going to hack NASA or US government or the UK government, then they're going to go after you. But the similar skill set, you can actually hack a game. Now, do you think a judge is going to like, hey, I'm going to put Mark in jail because Mark hacked League of Legends and then sold it? It like just doesn't happen. Like the judge is like, what the fuck's League of Legends? Or what is a video game? Plus, there's like no laws against it. So what you're seeing is a very similar skill set. What we're also seeing is that a lot of the cheating is actually going down to the kernel and the driver level, which is pretty incredible, but it's like the next kind of wave. Like that's how far people are going. So what's our strategy for that? Our strategy is essentially three things: prevention, detection, and deterrence. And we have like a multitude of things that we do. We've actually started writing our own software that is in the game client to help us encrypt on disk, encrypt in memory. So we're really raising the bar there. What we also do is we have data scientists. So we have like behavioral models that run, because you can detect a lot of things like through champion changes, through like MMR changes to like suddenly this person's winning like 80% of their games, or they're playing on a different client. We also have device ID technology within the client. So there's a lot of information that we have that we can actually analyze how people are playing. And then finally, there's like the deterrence. So we've been able to shut down a lot of scripting suites. So the scripting like suites they could be developed over like a year or two. They have a full business model. They have a full like, marketing team. They've got like obviously an engineering team. So a lot of these a lot of these groups are set up very similar to a company. And with our legal team and with a lot of the new tech that we've introduced, we've been able to shut them down a lot quicker. So the goal there is really multifold, and it's a staggered approach, and it's ultimately to have a better player experience. And we blogged about this, I think, in July of 2018. So if you go to engineering.riotgames.com, you can find an article on Riot's approach to anti-cheat, where we dive into the technology an awful lot more. So this is bug bounty. Now, within the last week, we've actually updated our bug bounty policy. You can see it. It's on hackerone.com/riot. And this is where we've introduced legal safe harbor. So we publicly launched it. This is about protecting our researchers. Obviously, some of it's about protecting Riot, but it's also set in scope in terms of what the researchers can attack, so to speak, or can research into. And we also produced some of the figures, right? So we want to be very transparent and honest with what we allow in bug bounty, but we're also being transparent and honest with what we pay. Now, there are exceptions where we actually go above and beyond, and we have in the past gone for like some pretty bad RCEs, but these are the explanations. So if you're able to execute arbitrary code on a player's machine for our client patcher, for our launcher, for League of Legends client, or any mobile application, then we will give you $10,000. An example would be stored cross-site scripting in chat. We think these are pretty much up there with the top of the industry. And like everything, we're always open to feedback. A lot of the changes and improvements we've made on bug bounty have been basically acting on feedback from players. Or sorry, not players, from researchers. So in comparison to 2015, the trends have like changed a little bit. I think when I was here in 2015, we had about like 50 researchers. We now have just under 220 researchers in our program. It's still a private program. 2015, we suffered a lot from domain hijackings, cross-site scripting. They've both gone down through a lot of our tools, through collaborating with development teams. We're seeing an increase in improper authentication. So it's 2018 and authentication is still a super hard thing to do. And as I said, we've paid about $1.7, $1.8 million since we launched in November 2014. I think the biggest payment, one-off payment, I think is around $75,000. I think that's the biggest for like one particular exploit. So we took the t-shirt and we scrapped it because t-shirts are so 2015. And we upgraded it to this metal. So it comes in a nice case. You got a lovely fist bump. But over here, you probably can't see it. Does anyone know who this champion is? Can anyone recognize it? Sorry? Brom? Yeah. So Brom is this support champion. We like to see ourselves as the support team. He's got like a super shield. If you play him too aggressive, it can go like really wrong, but you need to have like some aggressiveness. So we just felt that it fitted really well. And the reaction to the metal has been, or sorry, the coin has been awesome. And I think it's pretty cool. But that's our new reward for like a security champion. So that was a change there. One of the challenges that we've had a lot at Riot is around secrets. So has anyone ever had someone in a company leak an AWS API key to GitHub? Okay, there's got to be a few more because it happens all the time. Does anyone know Bob? And in Bob's company, the AWS API key was leaked. Cool, more hands. Got it, thank you for the tip. Right, so in Riot, we've had it. Now, fortunately, what's happened is it's been noticed mostly by Bitcoin miners, and Bitcoin miners are not like the most subtle of people, so it's been pretty noisy, so we detected it. Now, within GitHub, they have this new cool thing, and it's called Git Guardian, so it actually detects it. And about a year and a half ago, I was playing around, Russ and I were playing around with canary tokens. So it was like a couple of the teams testing like, hey, how quickly would this be noticed, right? So there's three things, right? Git Guardian noticed it within a minute and alerted me. So that's like super awesome. That's new tech from GitHub. How long do people think it took an attacker to like make a call to AWS with this leaked API key? Yeah, 7 minutes. 7. So you could see like the AWS STS, you know, like version of Who Am I? How long do people think bug bounty took? 3 days. It's like so disappointed. So one of the things that we did is we were like, in our evolution, we started to write tools, right? So we wrote a tool to provide temporary API keys so that when our developers are compromised or they leak an API key, that it's like a temporary thing, right? As opposed to a permanent thing. Because permanent credentials, I think everyone here will agree, aren't a really good thing. So we wanted to eradicate as many API keys that are permanent as possible. We've had really good adoption across Riot. And like we feel it's been a huge increase in terms of like player trust. Now, one of the things that we've learned over the last couple of years is it's good writing tools, right? It's good providing solutions. But if you don't measure it, then how do you know if your tool is actually any good or if people are using it? So we're really moving into like metrics. And so really quickly, the tool, you've got a web UI. Not everyone in AWS that uses AWS or Riot is technical. So you've got a web UI, and that will give you the temporary keys. It links in with our multi-factor auth internally. So in order to get a key, you now need 2FA. So that's a huge improvement in security, good removal of risk. You've got a command line option. As you can see, even though I'm a manager and have been for a few years, I can still manage the command line. Although usually what happens is I make a change, I push it to GitHub, and then one of the engineers fixes it. But it's super cool. AWS key -CLI -version help. You know, so it's got all the things you would expect from a command line. So it's really good also at being integrated into engineers' workflow. So our tools are now part of our engineers' day-to-day life, which is like huge. And like I said, we want measurability. So we want to know, are people using our tool? So we have our SecOps team runs an Elk stack. I think Elk is like the much cheaper version of Splunk, which isn't hard. And as you can see, you've got unique users, number of push requests, number of OTP requests, keys generated, and we took out the usernames, but we can see how many keys are created, the timeout. So this is really good because previously what we'd do is we'd make a proposal, do a solution, but we wouldn't actually know if it was being measured, right? So that's one of the big changes that we've made also. Now I'm going to finish by like going into like a little bit of story time. And as everyone knows, the cloud is magic. The servers don't actually exist. Everything is like an API, but there's nothing physical behind it. And it's not. What we've discovered is that this move to the cloud paradigm has changed a lot of people's perspectives, right? People don't necessarily believe that they need to do disaster recovery or backups. But if you look at the shared responsibility that Amazon talks about, you will find that, yes, you still need to think in the bare metal sense of like, I need a backup. So, story time. This is basically the biggest screw up I've probably ever made in my life at Riot. And I think a big part of the reason I made it was because I was burnt out. I moved from Ireland to LA, and I didn't take a break because I had all this pressure on me. I was like, hey, someone's paid for me to move country and my family. I need to like knuckle down, and I never actually took a break. And I think that's a huge problem in our industry, is that we burn out too easily, right? We don't take time out. And as a leader, that was a big learning for me, is that I need to lead by, taking time off. Americans struggle with like the O in personal time. I don't think they realize it's truly off. Most people in Europe realize that, off means you go away from work. So AWS, super quick way to iterate. How many people here use AWS? Just so, okay, cool. I just want to know how many of the terms I need to explain. So you can really iterate and develop and make products really quickly in AWS. And that's super useful for us because we want to deliver a player experience, right? We want to get stuff to the player as quickly as possible. So what happened in 2011, 2012, our web team wanted to deliver content to players, and they were waiting on operations to, I guess, like mine, and then take the mining and make a server and build a server, and they just got pissed off. So they were like, hey, screw you guys, we're going to go to AWS. And they went to AWS. Now, that very much meant that we were coming in after the fact. So that was like 2014, we were trying to think, how do we secure this? So one of the things that we did is we started running Security Monkey. Now, Security Monkey is awesome. The Netflix security team have probably done more for cloud security than any other team across like any other company. And I don't want to like bash the tool, but the problem with the tool is that it literally takes so much data. So if you're developing tools and giving them to developers, what's the problem with giving them a tool like this? I've literally given them a tool that is a red screen and told them, hey, there's 7,000 security groups that have a problem. Like, if I'm a developer, am I going to want to like do security after that? So the answer is no. A product owner, definitely not. So as a security team, we're constantly trying to work with teams to get security into their sprints. And if I give them a tool that presents everything in red, they're going to tell me to get lost. So we were like, okay, that doesn't really work, but we still need to do something. Why? Because incident response is super hard when you don't have visibility. Another thing with AWS is it's very easy to create stuff and forget about it, right? So in the bare metal days, it's hard to forget about it because the server is physically there. But in the cloud, it's not there. So if you're going to do incident response, it's bad enough doing it when you don't have visibility, but trying to do incident response on something that shouldn't be there in the first place is embarrassing, right? You don't want to be like on, you know, Wired or TechCrunch or the Register going, hey, Riot Games got hacked by a server that they no longer needed. It's just bad. So we were like, hey, how do we fix this? How do we give ownership attribution, give visibility? And with AWS, it's through tagging. So tagging is essentially metadata that you can use to tag most objects or resources in AWS to figure out who owns it. So we were like, cool, let's do this. Riot being Riot, what did we do? We wrote another RFC. We like RFCs in Riot. As you can see, there's now a version 2, but this was version 1, and it's how do we do AWS, right? But AWS in a way that's secure, and then we can trace ownership so that we can do that incident response. The key thing here is that if you look at the security monkey screen with the red, it's like literally decision paralysis. You don't know what to do because there's so many problems. So security is often about changing culture, changing behaviors. It's typically not about buffer overflows, you know, popping the stack and things like that. A lot of the time it's just getting people to realize what they need to do or make them get them to want it. So we shrunk the change. We focused solely on EC2 instances. So that's one element of AWS, not everything. And then we wrote an RFC, got feedback, iterated it, and then made that standard across Riot. So similar to the Secure Office RFC, we followed the same process. This is what we did. We came up with 3 tags, because if you come up with more tags, it's literally turtles all the way down. Like, you can then cause tech debt within tags. So we were like 3 tags, and then we did a schedule that was staggered, but we also created a schedule, as you can see, that was notification, shutdown, and termination. So within AWS, shutdown means it's still there typically. Termination means it's gone. So another customer typically owns it. And we set it out over a 12-week period. This is because we're trying to change a culture. We're trying to like get people's daily behavior or workflows to change. And we wanted to like do that in a staggered basis. So we wrote a tool called Cloud Inquisitor. For short, it's called Sync. And essentially what it does is if the AWS object in this instance, an EC2 instance, is incorrectly tagged, we remove it. If it's unowned, we remove it. We also added some features to the tool that enables us to check for features turned on. So this means that everything in AWS logs, it all logs to a central place. We manage our policies, so this means that developers cannot create policies that are way out of scope. And I talked about domain hijacking. It also checks for that. So we're like, cool. Those are the features. Let's write it. So we wrote it. Some of those features got added as we wrote and went through iteration. And then we're like, cool, let's turn it on. So we have the adapted RFC. We're engineers at the end of the day. We get super excited. We're like, cool, we're going to score. This is going to be amazing. And then Cloud Inquisitor turned into Murderbot. Now, this may not be obvious, but when your tool is called Murderbot, it's not a good thing. So the implementation didn't quite go as well as planned. We actually took down clubs. So if you're playing League of Legends in October 2016 and you're a member of a club and then it disappeared, that's my fault. I'd like to apologize. Clubs is back. What we discovered during it was that the team that ran clubs did not have disaster recovery. So remember, the cloud has a physical aspect. You need to back stuff up. They hadn't done that. Now, unfortunately, we have data in a lot of places, so we were able to get it. But look, we messed up the communication, and it caused a phenomenal amount of player pain. So if you remember, our player-focused organization, what does player pain look like at Riot? Well, Slack. Slack is probably the most toxic tool ever written. It's like IRC plus emojis plus reactions plus like instantaneous. And look, I'm a huge Harry Potter fan. I used to think I was in Gryffindor, but that night I got moved to Slytherin. And as you can see, I lost points, a lot of points for my house. But the little bit that I've highlighted, this is Margaret. Margaret is the product lead for clubs. So because we followed the process, we collaborated, we got feedback, you know, we engaged, we had really good intentions. She actually came in and supported us and was like, as her, like we'd knocked our product offline, but because we went through things the right way and we have like a culture of being embraced, yeah, she forgave us. And I'm still here, so I didn't get fired, but it really sucked. That's how I felt. But what we did is, we did a root cause analysis on an RCA, and we made it public. We did it transparently, all on Confluence. Our RCA meetings were open to everyone, and we got really good feedback. We even had an independent writer outside of the team run it, so that we could gain some of that trust back. As I said, communications, we could have done better. We could have made it more frequent. We could have reached out to other teams. Really interestingly, we discovered that there was confusion across Riot Tech about what adoption actually meant. So that was something that was super insightful. And we made a lot of fixes with engineering leadership with regard to RFCs. And one thing to do is, if you make changes to your code while your tool is live, it's good to test those changes. It's also good to have a code review. Who would have thought? Our notification code had bugs, right? We actually got a feature request in, super like player focused. We were like, cool, we'll do that, help you out as a writer. Didn't really test it, didn't get it reviewed, and then boom. But the real benefit of doing the RCA was that it actually brought us closer to a lot of people within tech. And we got really good feedback. And I'd like to call out that we followed the processes that the tech org has, right? So this is us talking in the language that everyone else talks in, not the infosec language. And then finally, February 2017, it was moved back into adoption, and we were able to start implementation. And I think since our tool has been running, we've shut down 3,500 EC2 instances, which is a huge reduction in security risk. It's also a huge benefit for our finance team. We've also since moved it on to EBS volumes, and in the last week we've just launched it for S3 buckets. So despite what Amazon tell you, S3 buckets are not a secure file storage solution. They are a file storage solution that's scalable with a lot of insecurities. But yeah, it's now adopted at Riot Scope. Everyone calls the tool Murderbot. We open sourced the tool at AWS reInvent last year. So it's on github.com/riotgames/cloud-inquisitor. We wanted to to purchase murderbot.com or murderbot.org. Surprisingly, they're already registered. So we couldn't do that. So Cloud Inquisitor was like the coolest name we could come up with. This is what it looks like. So it runs in our own account. This is the security account. These are multiple other accounts on the right-hand side. It uses STS Asymrole, and then it basically retrieves all the information, checks for security services, writes it all back to a database. We have an EC2 front end running Nginx, Python Flask, SQL Alchemy, and then the RDS database backend with MySQL as the database. So pretty standard tech. It's a little too monolithic because Lambdas are like the really cool thing and everyone's moving the functions and serverless. We will move to a push-based system eventually. There's just a lot of tech debt for it to remove. So this is what it looks like. A couple of things I want to call out is, again, everything's measured. You can quickly see how many instances are running, public IP. You can actually see per account. So replace Mars, Fightspace, etc., with like Game 1, Game 2, Game 3, all the other games that we haven't produced. And yeah, it's like measurable, visible, transparent, and it's very easy for a product team or developer to actually see what is their security posture within AWS with regard to like domain hijacking, what systems or buckets are missing tags, and things like that. And as I said, it's open source on GitHub. You don't have to go into the UI. You also email out notifications. And again, everything is like transparent. You can see exactly what you have to do in order to get your system back into compliance, right? So we're constantly thinking of like, how does this look from an audience perspective? How do we make this easy for the audience to understand and to use? In terms of like open sourcing it, if you're ever thinking of open sourcing, so we opened a source last November. We had a huge spike, a lot of interest, and then typically what happens is it falls down. If you go to a conference or summits, etc., and try to like evangelize it also, you get a little bit of a spike, but it's like less than 10 hours work a month now for us. So it's a similar sort of spike that we had with Bug Bounty. So how do we get to the Nexus? Well, the type of things that we want to do is, with RFC 242, we want to take our focus from Riot to the Rioter. So by this is, what I mean is, host-based protection, investigation with a very light footprint is our goal. We want many network points of presence. We really want to think about how do we have visibility when the Rioter is using Riot stuff off network, because I know some people on our SecOps team worry about that a lot. And that's really the way we're moving there, so that data finds its way home being the Riot security infrastructure, quickly. With auth, our goal ultimately is to have no permanent credentials and access policies that can be spun up and spun down dynamically within seconds. Like, we're a little bit away from that, but that's the overall vision. Like, we really don't want static credentials anywhere. And then we have multiple infrastructures, bare metal cloud. So we've already started this with Cloud Inquisitor. What we want to do is have platform independent solutions. So everything that we do should be platform independent, so that if Riot decides to go to Azure, Google Cloud, etc., that we can literally take our tools, and our tools can work regardless of the environment, because at the end of the day, it shouldn't be that difficult. It's just an API that we need to query. We've removed a lot of tech debt over the years. The problem with that is you can only go so far, right? So we want to work with new products a lot, because if we work with new products, such as R&D, or new products within League of Legends, or new products within like internal Riot, then we can create solutions that they can leverage, and these solutions can be shared. So the older tech or the older products can then leverage those. And that's really our focus. It's like, what can we do with the new stuff that we can just deprecate the old tech, so that we're not constantly trying to go back and remove tech debt. We've seen this work really well. Our AppSec team recently rolled out some code dependency stuff, and we're able to leverage off our shared infrastructure that our global infrastructure team have. So for Java and Go, we've built code analysis into the build pipelines for all dependencies. So that's an example of like reaching out, using tools that other teams have created that's like shared. And it actually reversed. It worked the other way when our global infrastructure team leveraged we have a service that we built that essentially you have to go through in order to access our production infrastructure, so our game infrastructure. And they were able to like query the endpoint that we provided, take that information, and then leverage it to raise up their network security, because everything is in code, right? Everything is queryable and machine readable. We're also going to continue with the measuring, because it's super important. We want to understand how good our stuff is it being used, where is it? And then finally, collaboration, right? We want to continue to collaborate, contribute more to OSS. We will hopefully open source AWS key in the next 6 months to a year. And we want to basically continue writing on our blogs. Engineering.Riot Games has got 3 security blogs in the last year, how we've evolved, Bug Bounty, and then anti-cheat. So the takeaway from the talk, if you're all still awake, is that we started with incident response, emergent, urgent work. We moved to like visibility, being embraced, working on collaboration and starting to write tools. And then we took those tools and we like added metrics, but we also integrated the tools into everyday workflow for our engineers. And in addition to being embraced, what we realized is that on occasion you have to block but it's not the blocking that's the issue, it's how you communicate it. So that's been a good learning for us, and we have blocked, which we wouldn't have done in like 3 or 5 years ago, and then finally continuing to measure. So that's the end of the talk. Thank you.
Okay. Thank you for the great talk and sharing the evolution of security at Riot Games with us, and also contributing to open source security in such a big way, I think.
Thanks.
I'm sure there are a lot of questions, so if we do a short show of signs, I'm going to get another microphone. Okay.
I tried to hit like every single team. I think I did.
So you mentioned that one of the bounties you paid out was like 75k. Can you elaborate at all on the bug that you paid out for on that?
Not entirely, but it was remote code execution within the client.
Cheers.
It's pretty cool, actually.
Back there.
I can't hear.
Let's try this one. Sorry. Can you handle it?
Better. Oops. Can you share any thoughts on insider threats? Obviously, you're a large tech organisation with, I guess, a lot to lose. You spoke a bit about threat actors on the outside. Obviously, to get the most out of abusing your services, someone with an inside position would be a useful ally. Put it that way. What as a security team are you doing about the insider threat?
Oh, insider threat.
That you can talk about.
So I think it's quite public that if you've been following Riot Games, that we've had leaks. So there's a thing called Reddit karma. I'm too old for this, but apparently it's really popular with the millennials, and it's we have a threats team, and they're pretty scary on some of the stuff that they do. We've got data, from the hosts. It's not that I don't know. I'm trying to figure out how much I can tell you. We work a lot with other games teams. With game teams within the company. We work with companies outside that are other gaming companies within a game security group. What we really try to do is we try to make the teams accountable for their own security. But we have host security stuff that we do that most companies would do, that's pretty good at detecting unintentional things. There is probably ways that people communicate on Slack that they're going to communicate exactly the same way on Reddit. Surprisingly, quite a few people after they leak actually admit it, which is easy. There's also certain stuff that's leaked that only certain people have access to. Does that make sense? So it's much easier to narrow that aspect down. With some of the work that we've done in the last year, we've greatly reduced the amount of people that have access to code, access to production. So from that aspect, an insider threat is easier to triage because less people have access to it in the first place. Things like, I guess I can talk about it because it's public, but we recently had someone leak a Slack conversation, and that's super hard because everyone has access to Slack. But again, there's various signals that are obvious when someone does that in terms of how they communicate and things like that. But overall, we have a culture that's we default to share. And we really try to do that because we want like an open, innovative, transparent culture. And with that comes like an acceptance of risk that just unfortunately some things are going to be leaked. I think what we've started to do is that when there are things that are super topical, like everyone wants to know, when is Riot releasing another game? And there are people that have access to code that could potentially be the next game. It's really difficult to manage the risk versus the benefit of being like open and collaborative. So in those instances, what we really do is, until they become less sensitive, we restrict the knowledge as much as possible. So again, it's kind of like a little bit like the anti-cheat stuff: prevention, detection, and deterrence. But we have a higher acceptance of risk because we value our culture and the ability to innovate more, if that makes sense. And then when we do detect insider threat, to add to the deterrence, we sometimes communicate it, right? But other times we don't. And again, every situation is unique. So it's not a great answer, but it's like literally every situation is different. And I think the big difference that we have is we have a lot more logging throughout our infrastructure than we had 3 years ago that makes investigations easier. Does that help?
Yeah, lovely.
Okay. Next up is like a short coffee break, so you can continue the discussion at the coffee table, and we will continue here at 4 p.m.